Allow me to introduce you to the celestial body that holds the most significance for us all, the sun. You might say, I already know the sun. I've seen it every day for my entire life. Yes, Earth's star is our lifelong companion. It is our mood booster, our plant grower, our sometimes too much of a good thing skin scorcher. We all know, love, and admire the sun. I'm an astrophysicist. I live for studying the sun, its complexity, and the weird and powerful weather system it creates. Sometimes when I get so into it, which is most of the time anyway, my wife will ask, are you also married to the sun? and I'll say, technically no. But if it doesn't upset you too much, yes. Now, having said that, I'm not sure where I'm going to sleep tonight. So I can confirm that we know the sun better than any stellar system in the whole universe. But I'm going to let you in a little secret. Sometimes I feel like we don't know the sun at all. As a child, I was captivated by the sky glittering with stars, which are nothing but distant suns. Lie on your back on a summer night, look up at the heavens, and there you have it. Whichever direction you look, there is a star shining at you, another sun. That was the start of the journey of wonder and curiosity. Stars come in all sizes and flavors, from monsters to dwarfs. If we were to drop the largest known star in the universe into our solar system, it would extend well beyond the orbit of Jupiter. The smallest is about the same size as the planet Saturn. But no matter the size and type, stars hold great significance for us. We are all made of stardust, star babies. Yet no star holds greater significance for our past, our present, and our future than our very own. The sun is responsible for life on Earth, powering photosynthesis, warming the planet, providing clean and free energy. But it is also violent, explosive, and unpredictable. Here's what I mean. The northern lights are beautiful and mesmerizing, right? On September 1st, 1859, people could see aurorae, even in daytime, around the entire globe. Turns out, that was the result of the most intense geomagnetic storm in recorded history. This was the Carrington event. It was likely a giant coronal mass ejection, or CME, that disrupted telegraph lines and sparked fires at their stations. Can you imagine the repercussions of such a storm today? It could shut down the entire power grid, not for hours, but weeks and months, or even years. The potential for human distress in the affected areas is well beyond our scale of comprehension. The economic impact alone could be in the trillions of dollars. So learning about the one star in the universe that humans cannot do without is vital. And that's what physicists like me are trying to do. So what do we know already? The sun holds over 99.8% of the solar system total mass. Its sheer size is mind-boggling, requiring more than 1.3 million Earths to fill its volume. All of that mass is in the form of plasma, a glowing soup of electrically charged particles. At the solar core, gravity is exceedingly high, producing temperatures in excess of 15 million degrees Celsius. The extreme pressure forces the protons to come together and diffuse into helium while releasing bursts of energy. This is nuclear fusion. And if we can replicate this process sustainably on Earth, it would provide almost limitless clean energy to power the entire globe. Many of us have witnessed total solar eclipses like the one in 2024. This fascinating celestial spectacle has captivated humans for millennia. As the moon gracefully positions itself between us and the sun, the solar corona bursts forth in all its majestic splendor. But the corona also harbors some of the most perplexing phenomena. The solar surface is plenty hot, 6,000 degrees, hot enough to melt anything we know. But in the corona, we're talking millions of degrees Celsius. How can it be over 300 times hotter despite being the sun's outermost layer? Physicists have suggested since the 50s that all of that heat must generate a constant outflow of particles. This is the solar wind. It speeds away at up to 3 million kilometers per hour. At that speed, you can get from the Earth to the Moon in under 20 minutes. This cosmic stream is like celestial rapids, and that's where we live. Behind all this is the sun's magnetism. As solar magnetic fields twist, bend, and tangle, they store enormous amounts of energy. And when they snap, huge explosions like flares and coronal mass ejections release this energy and turn it into heat and accelerating the plasma. It takes only a handful of these strong events to fulfill our current energy needs for some 200,000 years. That is the whole span of modern humans' existence. The sun does that in minutes to a few hours. These same explosions propel particles to nearly the speed of light and turn them into formidable hazard to spacecrafts and to humans in space. Does the loss of 40 SpaceX satellites ring a bell? A moderate solar storm knocked them out. Our power grid can fall victim, like in March 1989 in the northeast of the US, Canada, when a succession of solar storms caused an intense geomagnetic storm. Even deep seas can be affected. In 1972, dozens of sea mines spontaneously exploded. The likely cause? You guessed it, a powerful coronal mass ejection. So we need to learn how the sun does all this and more. Since the dawn of the space age, NASA has wanted to fly a spacecraft as close as possible to the sun to solve these mysteries. But getting very close to a star is extremely risky and really hard. How would we protect a probe from just melting? How could it adjust for any problem on its own when you cannot communicate with it? Until recently, we simply didn't possess the technology. In 2018, that all changed with the launch of Parker Solar Probe. Parker Solar Probe is the first spacecraft to ever fly through the solar corona. It has revolutionized our understanding of the sun. In 5+ years, we've already learned so much. We now know how the solar wind is generated at its source. We are the closest ever to understanding what heats and accelerates the plasma in the corona and the solar wind. And we have the most detailed observation of coronal mass ejections. Can you hear that? This is one of the most powerful CMEs ever recorded. It erupted on September 5th, 2022, and it was traveling at more than 2,500 kilometers per second when it hit our brave probe very close to the sun. For days, we didn't know whether Parker Solar Probe made it or not because it was on the backside of the sun. But once it emerged on the other side, it called back saying everything is fine, and we have a ton of data for you that will give you an unprecedented look at how these events accelerate particles to almost the speed of light and sweep almost everything in their way, leaving a near-perfect vacuum behind. And that is just a sampling. We cannot catch a breath with this mission. Every 3 months, we have a close approach to the sun and a new load of data to investigate. It's overwhelming at times, but this data will serve many generations to come. Parker Solar Probe is a true mission for the ages. So are you curious, how did we do it? Parker Solar Probe is not a large spacecraft. It could fit under a basketball hoop and carries about half the weight of a compact car. But it is a marvel of technology. The only thing standing between the probe and incineration is an ingenious 11.5 centimeter thick, 2.3 meter wide carbon foam shield. On Christmas Eve 2024, the shield's sun-facing side will endure about 1,000 degrees Celsius. About 1 meter behind, it's almost room temperature. How does Parker shed all that heat? This special ceramic coating on top of the heat shield reflects as much light as possible. The heat shield itself absorbs a huge amount of heat and radiates it elsewhere. Meanwhile, a network of tiny pipes runs through the solar panels, extracting heat and expelling it through the radiators. It uses a liquid-based cooling system. The liquid is a simple gallon of water. Cheers. All this system will be operating on December 24, 2024, when Parker Solar Probe achieves humanity's closest ever approach to a star. This will be a monumental and audacious achievement. In 69, we landed humans on the moon. In 24, we're going to embrace a star. So all this is very cool, amazing science, and really fun to geek out about. It also happens to be vitally important for your lives and to mine. Delving into the sun's history, we discover periods when it entered long, tranquil phases that lasted for decades. During these times, called the solar grand minima, solar activity diminished to the point of near non-existence, along with extreme climate conditions on Earth. One such episode lasted for an astounding 7 decades, from 1645 to 1715, and it coincided with the Little Ice Age. This episode seems to occur every 200 to 300 years or so. Now, here's the thrilling intrigue. We are overdue. Is the sun about to enter a new and extended lull of minimal activity? When will it happen? How long will it last? How deep will it be? We don't know. The most important thing, however, is what impact this phenomenon could have on our lives, our movements, our energy, our food sources. How will it affect our climate and our atmosphere? The sun is not a driver in Earth's current changing climate. But if it enters an extended period of tranquility, how much could it slow the pace? Again, we don't really know. To answer all these critical questions that shape the fate of our society, we must unlock the sun's secret from its fiery core to its outer reaches. For our future, for the world we leave behind, for our children and theirs, we must transform the way we observe the sun and deepen our understanding of how it influences its surroundings, in particular our cherished planet Earth. Without doubt, this undertaking poses formidable challenges. But it's another adventure unlike any we've been on before. Here lies yet again another opportunity to transcend ourselves and forge ahead with our epic journey of progress and prosperity. For better or worse, the sun dictates our past, our present, and our destiny. Thank you.